This is the last section of chapter 4. We're going to talk about quadratic inequalities. And inequalities are those expressions that have the less than, greater than, less than or equal to, greater than or equal to. So we're going to deal with two different types. We are going to graph quadratic inequalities and we are going to solve quadratic inequalities. So if you look really quickly before we actually start, the graphing quadratic inequalities, I want you to notice that these are inequalities with two variables. We've got the x's, which we've come to expect by now, but then these ones have y's. So anytime that you have y's and x's, that's where you get like the full graph of a parabola. And then solving quadratic inequalities, if you look at all these, there's no y. You've got the quadratic equation, but then just 0 on the other side. And so these are more similar to the ones that we like solve by factoring or the quadratic formula or something. So we're going to start with the graphing. I'm going to write down a quick step-by-step for you, and then we're going to graph each inequality. So first step, graph the related function. And so let's go back and forth between writing down the steps and then actually following through on the steps of this first example. So we want to graph the function. So the function that we graph is y equals x squared plus 2x plus 4. All right, and the way we do that is the same way that we did in the very first section. We are looking for the vertex, we're looking for the y-intercept. So when we get those two, we can get a pretty decent graph. Okay, so let's set up our coordinate system. Okay, so our y-intercepts is always just the constant that's hanging on the end, because if you plug in 0 for x, this would be 0, this would be 0, and then I'd get a positive 4. So my y-intercept is 4. I can start there. So there's the first point that I plot on my graph. And then for the axis of symmetry, remember my formula is x equals negative b over 2a. So I take a negative b, which is 2. So negative 2 over 2 times a. So 2 times, remember there's technically a 1 here. 2, so that is a negative 1. So I'm going to graph my axis of symmetry right here at negative 1. So I'm going to plot that dotted line, and that's the line of symmetry for the parabola. I could fold my parabola in half over that line. All right, and then the last thing I'm going to plot is the vertex, and the vertex is the point that sits right on this line. So in order to find the point that sits right on this line, I need to plug in this x value. This x value is a negative 1. So y equals negative 1 squared plus 2 times negative 1, and then plus 4. So this is 1 minus 2, which is negative 1, and then plus 4, which gives me 3. Okay, so that's my vertex. I'm going to plot that. So right there. All right, and then the last thing that I'm going to do is I'm going to mirror image my point onto the other side. Okay, so this point right here, since this is a line of symmetry, I can mirror image that point right about there. Okay, and then I connect the dots, make a parabola. It's going to look like this. Okay, second part, step 2, test a point not on the parabola. And this becomes just like the inequalities we did with lines or with absolute value or whatever. You do a test point and then you end up shading whatever region you get, like the true or the false. One thing I'd like to point out, I forgot to mention, this is a less than or equal to, which is why I graphed a solid line. All right, so we're going to do a test point. So one of the greatest test points ever is 0, 0, and as long as it doesn't fall on the origin, or as long as it doesn't fall on the parabola, we can test it. So is 0 less than or equal to 0, I'm plugging it in here, 0 squared is 0, plus 2 times 0 is 0, plus 4. Is 0 less than or equal to 4? Yes, it is. So that means that 0, 0 is part of my solution. And so what I do is I shade the appropriate region. So for part 3, let's say shade accordingly. So since 0, 0 turned out to be true, like I said, that means 0, 0 is part of my solution set. So I shade accordingly, meaning I shade everything kind of underneath this parabola. All right, so that would be my answer. I've got the parabola, and then I shade everything kind of underneath it. All right, next one. Let's do this one really quickly. Okay, so I'm going to graph the related function, which is y equals negative 2x squared plus 3x plus 5. Okay, so starting with my y-intercept. So my y-intercept is always just the constant on the end if I'm in standard form. So that would be a 5. So there's my first point. Then I'm going to find my vertex. My axis of symmetry. My axis of symmetry, the formula is negative b over 2a. So negative 3 over 2 times negative 2. So that's a negative 4. So my axis of symmetry is 3/4. Not the prettiest value, but so let's say that's 1. So 3/4 will come just a little bit there. And we're just trying to get a sketch of this. It doesn't have to be the most flawless thing in the world. Okay, so for my vertex, I'm going to plug in 3/4. Okay, so I take that, and now that is not exactly the prettiest value in the entire world, but what you can do is you can plug that into your calculator, and it'll give you a decimal, and then you can plot that. So, unfortunately, I can't pause and restart my video. Let me grab my calculator. 2 seconds. Okay, so we are just going to plug that right in. So we don't need it to be painful. We don't need to deal with anything crazy. So we're just going to plug this thing right in here. Okay, so negative 2 times 3/4 squared, and then plus 3 times 3/4, and we're just going to have it give us a decimal, plus 5. All right, so let's see that screen there. Just plugged it right in. And then make sure you hit Control Enter if you want them to give you a decimal. So 6.125. So 6.125, so if we go back to my axis, so here's 6.125, would just be the tiniest little bit higher. Okay, and then the last thing I do is I'm going to mirror image a point on the other side. So if this is 3/4, that means we're 3/4 of a unit away. So 3/4, if I want to double that, that would be 6/4, which is 3/2, which is 1.5. So at 1.5, I put the exact same value right here, and I can mirror image it. Okay, so while I'm graphing my related function, I need to look at this sign right here. That is purely a less than, and so that means that my parabola actually needs to be dotted. Okay, so there's my graph, and we're kind of recapping stuff that we did in the very first section. Then I do a test point. Notice 0, 0 is not on my parabola, so it's free to test. So we want to know, is 0 less than or equal to, when I plug in 0 here, I get 0, plus, when I plug in 0 here, I get 0, plus 5. So is 0 less than 5? Yes, it is. So that means that 0 is part of the true region. So that means that I shade the region containing 0, 0. So with this one, it would be everything kind of inside of that parabola. All right, so that's the first kind of topic that we're doing. The next topic is solving quadratic inequalities. Okay, now these are the ones, like I said here, these are the ones that have a 0, not a y. So I'm going to give you some quick guidelines for these two. So solving ax squared plus bx plus c is less than 0, what we're basically looking for is something very similar to when we set them equal to 0. We'd solve by factoring, we'd solve by the quadratic equation, even completing the square, and what we're looking for there is the x-intercepts, technically. Because if you take one of these and you set it equal to 0, you're looking for x-intercepts, because that's plugging in 0 for y. So let me give you a couple of quick sketches. So what we would do to solve these is you would graph this function right here. So we've got two options. If a is positive, then your graph would look something like this. Okay, so if a is positive, your graph would look something like that. Remember, your parabola opens right side up. If a is negative, then your parabola would look something like this, and it opens upside down. Okay, so this would be an example for a negative value of a, and that's that leading term right here. So that's what tells you if your graph is right side up or upside down. So what we were looking for, we've got this less than 0, and so these are the points right here and right here where your parabola is equal to 0, because those are your x-intercepts. So if you want to know where the value of the parabola is less than 0, that means we want to know when our parabola is below the x-axis. All right, so we are looking for where our parabola is below the x-axis. So that means that we're looking for this strip right here. If I plug in one of these values, my parabola will end up below the x-axis. Okay? If I want to be below the x-axis here, that means I'm plugging in anything over here. If I plug in something over here, I end up below the x-axis. If I plug in something in the middle, I end up above, so that doesn't count. If I plug in something over here, I end up below the x-axis. Okay, so I've got this one inequality for this one. I would have two inequalities for this one. It'll get a little easier once I give you actual examples. Okay, so now greater than 0, same two scenarios. Maybe a is positive and I have a parabola that looks like this. Or maybe a is negative and I have a parabola that looks like this. Okay, so two scenarios. This time, though, we are looking for the x values for which the graph lies above the x-axis. Because again, here are the points where you're right on the x-axis. Those are the x-intercepts. Now we are trying to identify the x values for which the graph lies above the x-axis. So if I plug in x values over here, I'll end up above the x-axis. And if I plug in values over here, I'll end up above the x-axis. Here, I'm above the x-axis for this little bump right here. So if I plug anything in between these two values, I will end up above the x-axis. So that's kind of a visual of what we're looking for here. So for example 2, we want to solve each inequality by graphing. So let's start with the first one. Let's start with part A. All right, so 2A, and we're just going to kind of skip around and do one of each so the video doesn't get crazy long. So solve each inequality by graphing. So we're going to start off by graphing this function right here. And I just want to rearrange everything and write this in a different order. So we want to know when x squared plus 5x minus 6, if you flip this inequality and read it backwards, we want to know when this thing is less than 0. Remember, anytime you write these in different orders, you actually flip the inequality. Because if we want to know if 0 is greater than the equation, it means we want to know when the equation is less than 0. So that's what we're solving. So to solve by graphing, we need to actually graph the equation, which first means that we are going to come up with the x-intercepts. We want to know, most importantly, where we are going to lie on this x-axis. All right, so let's set up a little graph right here. So to find our x-intercepts, we are going to set this parabola equal to 0. All right, so start with that. We take the related equation, which is the equation by just replacing the inequality with an equal sign, and we start by finding the roots, or the x-intercepts. Okay, so we set this equal to 0. What we're actually going to do is we're going to factor this down, because this is just a nice, neat trinomial. Okay, so I take these, -6, and I start with my x here and x here, because when I refoil, x times x just gives me an x squared. If there were a 2 or something in front of this wouldn't be so simple to factor. But I want to know what's going to multiply to a -6 and add to a +5. Okay, and that would be a +6 and a -1. Those would be those two numbers. Okay, so I start by factoring, and then I use that zero product property to set each factor equal to 0. Okay, and then I solve each equation. So here I subtract 6 from both sides and I get a -6. Here I add 1 to both sides and I get 1. So those are my two x-intercepts. So we're going to sketch the parabola. Very, very light sketch of it. So x-intercepts, 2, 3, 4, 5, 6. Okay, and then my other x-intercept is at 1. Okay, so I need to know if it's going to be a downward parabola or an upward parabola. Since my x squared is positive, that means it's going to open up. So like I said, we are doing just a light sketch of what this parabola looks like. The important part is that I know the x-intercepts. So anytime you're doing this, the inequality stuff, all I need to know is the x-intercepts. Okay, so now what I'm looking for is where this graph is less than 0. So if you kind of follow this pattern here, my graph looks like this. I want it to be less than 0, which means I want the range of x values in between my x-intercepts. Because this right here, this is where my graph is below the x-axis. And so if I look at this whole region, if I plug in any of these x values in this region, my graph pops down below the x-axis. So I need a way to describe that. So it's in between -6 and +1. And so what I write, remember my 3-piece inequality? To say that I have to fall somewhere in between -6 and 1. Looks like that. All right. Next one that I'm going to do, we actually will do this one as well. So this one, if I want to take this, I want to factor it down, I'm going to take x squared, negative x squared, plus 3x plus 10 and set it equal to 0. And so that's how I will find my x and y intercepts. To make it easier, I could move everything over to the right. Okay, so I'm going to move everything over to the right, so I'll have 0 equals positive x squared minus 3x minus 10. That is going to make things way, way easier since I have a positive x squared. So I'm going to factor this right-hand side down. So I start with my x times x. That gives me my x squared. Again, if there were something in front of the x, even like a negative, this would be more complicated. So I want to know what two numbers are going to multiply to negative 10 and add to negative 3. And that would be a negative 5 and a positive 2. Okay, and you can always refoil if you don't believe me. Okay, so then I do the zero product property. I set these both, x plus 2 equals 0, or x minus 5 equals 0, and solve. So I get negative 2 or positive 5. Those are my two x-intercepts. So I'm going to start there. Okay, so my two x-intercepts, I have one at negative 2, and then I have one at positive 5. Okay, so I've got my x-intercepts. Really, just to get a quick sketch, all I need to know is whether this thing is going to be flipping up or flipping down. And because of the negative in front of the x squared, it's going to be upside down. So just a quick sketch, looks something like that. Don't need to know the vertex or the axis of symmetry. When I'm doing this type of problem, all I need is the x-intercepts. Okay, so it looks something like that. I want to know when this parabola is less than or equal to 0, meaning I want to know when the parabola ends up below the x-axis. And I've got a piece here, so if I plug in any of these x values all the way to the left, I'll end up below the x-axis. Here I end up above the x-axis, so that doesn't count. And then if I plug in anything over here, I end up below the x-axis. So these x values that I have shaded are the ones that I want for my inequality. So this piece right here, these are all the values that are to the left of negative 2. So I'm going to write x is less than or equal to negative 2. The reason I have the or equal to here is because I have the or equal to here. With this one I didn't, so I didn't include it. And then or, I move to the second piece over here, because this is like an or graph. This right-hand side, this is 5, and then everything to the right. So then I'd say x is greater than or equal to 5. So that would be your answer for that. Okay, I am going to do one of these. Instead of A and B, I'm going to do just A, because this one's a little weird. So I want to set this equal to 0. X squared minus 6x plus 2 equals 0. And this is to find my x-intercept, so I know how to start my graph off. And so I'm looking for, again, my x-intercept, so I set it equal to 0. Can try to factor, just like I did up above. X times x gives me my x squared. And I'm looking for something that multiplies to a positive 2 and adds to a negative 6. The only thing that multiplies to 2 are 1 and 2, and there's no way to make that add to a negative 6. So this does not factor. What we will quickly learn is if you can't factor something, we can do the quadratic formula. All right, so I'm going to take this and I'm going to do the quadratic formula. So x equals negative b, it's positive 6, plus or minus the square root of b squared, gives me 36, minus 4 times a, which is 1, times c, which is 2, and then all of that over 2 times 1, which is just 2, of course, equals 6 plus or minus. 4 times 1 times 2 is 8, so I have 36 minus 8. That gives me 28 over 2. So now, since I am trying to graph, normally I've told you to just simplify this down and then leave it, but since I am trying to graph, I actually do want to get a decimal approximation this time. So I take 6 plus the square root of 28. Oops. Let's try that again. Open up a fraction. 6 plus the square root of 28 over 2. And that gives me, oops, that's not even on the screen. There we go. That gives me about 5.6. Let's do 2 decimal places. 5.65. And then if I do the other one, I do a fraction again. 6 minus the square root of 28 over 2. Okay, and that gives me about 0.35. Okay, so those are my x-intercepts. Give myself a sketch over here. So I go 1, 2, 3, 4, 5, 6. So 0.35, just estimate it, right about there. And then 5.65, estimate it right about there. We are just looking for estimates here. And then this has a positive x squared, so I know it's going to open upward. Okay, so just a quick sketch is all we're looking for. The x-intercepts are the only thing that matters here. Okay, I want this thing to be greater than 0, which means I want it to be above the x-axis. So that starts here. Anything to the left, and I'm going to get a parabola above the x-axis. Anything to the right, and I will get a parabola above the x-axis. Okay, so I want to describe this region. So that would be all the x values that are less than 0.35. I use just a less than because this is just a greater than. I don't have the or equal to. And then or, since this is an or graph, this piece right here, which are all the x values that are greater than 5.65. Okay, so that is my value. So if you can't factor, sometimes you might have to use the quadratic formula, and then you get these decimal values. Okay, so we're going to skip through a few on the back here. This one you'd have to use the quadratic formula as well, so it's very similar. We are going to skip over the story problem, and then we're going to take a look at these. These ones are slightly different. We're going to solve these ones algebraically. We're going to solve them without graphing. So this one, first of all, we need to get it into standard form. So we're going to add 6 to both sides. So we're still solving the same thing. So for this one, we're still looking for where this parabola is less than 0, meaning where that parabola is below the x-axis. But we are going to set up using something called the sign chart. Okay, so we want to solve the related equation. And we can at least attempt to solve that by factoring. If you can't solve it by factoring, then we turn to the quadratic formula. Okay, so I start with x and x because we're dealing with just some simple ones here, just an x squared. So x times x gives us x squared. And we want to know what multiplies to 6 and adds to 5. And that would be a positive 3 and a positive 2. Okay, next thing is I use the zero product property to set them both equal to 0. And then I solve each equation. So here I subtract 3 and I get x equals negative 3. Or I subtract 2, and I get x equals negative 2. So those are my two solutions. Those are my two x-intercepts. Okay, now this one, I'm going to plot negative 3 and 6. I'm sorry, I'm going to plug negative 3 and negative 2 on a number line. I'm not actually going to graph the parabola. So I'm going to plot them on a number line. So set up, your nice, neat number line here. Okay, so I've got, here's 0, for instance, and then negative 1, negative 2, negative 3. Just got a bunch of values here. Let's label the important ones. Here's negative 2, and then here's negative 3. Okay, so what this does, we're going to use dots for right now. We know, let's see. Okay, so this one actually, we're going to use open dots, I'm sorry. We know that these values themselves are not actual solutions, and that's because I just have a less than or equal to. Okay, so we're going to use open circles since we know they're not solutions of the original inequality. So now what happened is I have, my number line is now divided into 3 different intervals. Okay, so I have like this interval right here, all the numbers to the left of negative 3, and then I have all the values in between negative 2 and negative 3. Even though there aren't any whole number values, I still have decimal values. Okay, so there's this region right here, this region, and then the region from negative 2 on. So I am divided into 3 different regions here. Okay, what I'm going to do is I'm going to test a value from each interval to see if it satisfies the original inequality. Okay, so I'm going to test a value from each interval. So here I could test like a negative 4. Okay, so I'm going to test negative 4, plug it into the original inequality. Actually, you could plug it into the factored version because the factored version make things really easy. So negative 4 plus 3. And then negative 4 plus 2. We want to see if that comes out to be less than 0. And so when I plug this in, I get a negative 1 times a negative 2. Well, that comes out to be positive, so it is not less than 0. Okay, then I'm going to test something in between in that next interval. So now I want to test like negative 2.5. So plug it in here. So negative 2.5 plus 3, and then times 2.5 plus 2. We want to know if that turns out to be less than 0. Oops, negative. Okay, so this comes out positive. Negative 2.5 plus 3 comes out positive. And then this comes out negative. So a positive thing times a negative thing does come out less than 0. So that is true. Okay, I'm going to test one last thing. Now I'm going to test something in this region. So always test 0 if it's available. So plug it in here. So 0 plus 3 times 0 plus 2. Does that come out to be less than 0? And that is false. No, it is not, because that's a positive, it is not less than 0. All right, so when I test everything here, the only true region that I got was the one in the middle. Okay, so the true region that I got was that region right there. Okay, so to describe that region that is in between negative 3 and negative 2, but not including them. So I write negative 3 is less than x, not less than or equal to, which is less than negative 2. Okay, so that is your solution set. And I apologize for the length of this video, but I do want you to see one more here. Okay, so we solve the related quadratic equation. So we're going to set this equal to 0 and solve. We're going to try it by factoring first. Okay, so we want to know what multiplies to 30 and adds to 11. That ends up being a positive 6 and a positive 5. All right, so I set these equal to 0, and I will come up with my x-intercepts. So subtract the 6, and I get negative 6, or subtract the 5, and I get negative 5. So just like before, I'm going to plot these on a number line. So remember, what this does is it divides my number line up into 3 different intervals. And I'm only drawing this here just to kind of give you a visual. So 3 different intervals, 3 different possibilities. First of all, I'm going to start with dots on these 2 because they are part of my original, because this is a greater than or equal to. Okay, so I'm going to test 3 different values just like I did up above. Test something in here. So let's use like a negative 10. Something less than negative 6. So plug it in right here. So negative 10 plus 6 times negative 10 plus 5. Does it come out to be greater than or equal to 0? Let's find out. So this is something negative. This is something negative. It does come out to be greater than or equal to 0. True. Because negative times a negative is always positive. And I can test something in here. It's got to be a decimal, unfortunately. So something like negative 5.5. If I plug that in here, negative 5.5 plus 6 times negative 5.5 plus 5, does that come out to be greater than or equal to 0? Well, this comes out positive, and this comes out negative. So something positive times something negative, no, it's not greater than 0. So that region is false. Last thing is I test anything above negative 5, which I always use 0 whenever I can. So plug this in. 0 plus 6 times 0 plus 5. Does that come out to be greater than or equal to 0? Well, this is positive and this is positive, so yes, it comes out to be positive. Okay, so my true regions were this region right here and this region right here. Those 2 regions came out to be true. So that's an OR graph. These are all the values that are less than negative 6, and I use less than or equal to because of this original inequality. Or, and these are all the values above negative 5, and again I use the or equal to because this has the or equal to. So that is my solution set. Alright, again I apologize for the length, but I wanted to make sure that we got through these because that's going to be the confusing part for you. Alright, all done.